Shoot. Nice. So let's continue our. Wait a second. Okay, let's continue. Oops, this is confidential. So the next thing is we are going to continue our MQTT implementation part 6. PSCE goes into C MQTT. Okay, so the last time which we left is was where were we? Hmm. Man, the first part, this is taking longer than I expected. But well, you gotta do what we gotta do. So we unpacked the string 16. Okay, so let's just review what we did. Unpack string 16 means I have some buffer or a pointer to some pointer that points to some buffer. Okay, so I realized some time ago that why can't it be a single buffer? Because if you think about it, by single buffer I mean by single pointer, not double pointer. If you think about it, yeah, this is some external API, right? I think I said it earlier also, but I wasn't much sure about this, but now I think I'm fairly sure why it is a double pointer. If we think about it, this is some external or some external APIs, and let me write this. Let me draw something. Yeah. So yeah, this is right. This is good. So the thing is, let's call it some. It's some buffer. It's not a buffer because buffer is already what we are passing. And then it would conflict with this. Okay, let me think about it a little bit. Or let me just make something then completely new. So let's just say this is some buffer which contains, let's just say this is my, which contains actual data bytes, or let's call it, it is what it is. It is a byte stream, right? So it is a byte stream. and I have a variable called buffer. How do I do? Like, let's just say, so this is the buffer that we have, and then just call it some, let's call it head or something like this, because this is what it actually is. And this is inside some, how do you send it back? Send to back. Okay, so this is inside some axis or something, let's just say some packet or anything like that, means it is inside. And this is what I mean by external API. So this is our code. This is some boundary of some sort, some like internal thing or whatever you make sense. Like in an abstracted way, it's just a boundary, and this is our external API which cannot access this buffer direct. My bad. Which cannot access this buffer directly. So in that case, yeah, let's just call it here. Now I think you get the idea what I'm trying to say. So this is my external API which wants to access the byte stream. This is my byte stream here, but it is within some boundary, some boundary, and I can only access it via this exposed thing. It could be variable, function call, whatever. And in this case it's a simple pointer because this is very simple. So this simple pointer, what it does, it just initially points to the very first location. And now being a external API, I have, and I want to access this byte stream, but what I'm given with is this. So I don't have access to this, but I want to access it, so I will do this via this thing, and in this case it is a pointer. So that is the reason I need a double pointer, because only then this can happen. And given the compiler needs some side information and type information, makes it a double pointer. Otherwise, let's just not go that deep. I think it is fairly clear why it has to be a double pointer. And I think this is pretty good. Pointers are good. Interesting actually. Good or not, that depends on the implementation, like how you use them. But yeah, this is it. I think it's cool. Moving forward, we have done this. So what this essentially does is it is from this byte stream that this buffer guy points to, in whatever way, from this byte stream I want to get a string into this area, which is again a double pointer. How do I do this is I unpack 16 bits. Why I'm unpacking 16 bits is because if you remember that our packet that inside the protocol that was that had what you call string. No, yeah, okay. Inside the protocol there was a connect packet called subscribe, right? And that subscribe has topics, and the topics was nothing but strings, and the size of those strings were encoded in 2 bytes, and hence I have here the 2 bytes. So from this location I get 2 bytes, which would be my length of the string, like how big my string is. And from this information I allocate some memory and I unpack bytes into that memory. As simple as that. Then I return this length, which implies like how big the string that I uh, extracted from this buffer is. Right, now we are onto the right data. So we pack 8-bit. I think this is what serialization and deserialization is happening. So later in the series, maybe I'll rename these. We'll see. So now we'll, okay, so this is packing 8-byte. What this means? So from this buffer into this value, and oh, no, this is serialization. This is deserialization, is it? Yeah, unpacking is deserialization and packing is serialization, because you take single byte, you put it in the buffer, and you increment the length pointer, or you increment the head. See, if you could have make a variable with this being a head, then it would be easy to follow. So similarly, if you're packing 2 bytes, which means these are the 2 bytes, you want to pack them into this. Here you convert it into the network order, host to network short to this, and then what do? This is your destination, your source, and this many bytes. So this is serialization, and then you increment this. And I think why it is very becomes very simple to serialize and deserialize is because these are strings, right? And they're nothing but string is nothing but a chain of characters. So there's not a lot to pack and unpack to serialize and deserialize. I mean, I think this is powerful, but it comes at a cost that strings are very costly in terms of memory, and when you send them like this, it becomes computationally costly as well. I don't know. I'm just a noob here. I'm just thinking. Because like if you would have put it in some structure like C struct and something, then there would be many types. Now, I'm we'll see. So I have to pack single byte. How do I do that? So I'll say that pack 8 byte. Where do I want to pack? I cannot use constant. See here this, but I'm moving this away. This can't be constant, so it's a double pointer. This is a buffer, and this is the value that I want to pack. Now how do I do that? Packing means I just have to store this value at this buffer location. And what is this location? It's um, well, I first have to access the head, which I do doing this at this location, put the value v, but I can't do that because that is still a pointer. Now this is what I have to do, right? So what I was saying earlier, like you could have put it in a better way, like define it a head or something like this. Okay, so it's a pointer to int, just call it head, and this is this, and you now I say HAD head plus equals to, well, in this case it is 1, but let's just for the sake of symmetry, I'll call it a val. This is how I've been doing this, right? Size tval, yes. I think I'm I'm thinking like whether putting the actual type in here is a good idea or putting a variable name is a good idea. In one case, when I put type, then it is pretty clear like what I'm doing, like I'm calculating the size of this type. But sometimes, like in this is very short, so it makes sense to it doesn't make a much difference to put it 32-bit, to put it size, sorry, to put it type or put it value, variable name. But if this was some long function, in that case, semantically it would give me more information about putting the variable name here. For example, let's just say this. For example, let's just say this value variable has been defined somewhere very top of the function, and it is named in a very descriptive way. Then putting simply unsigned int 32 doesn't convey some information, because in that case you are saying like uh, update this by the size of 32-bit. But when I say update this by some name and the size of that name, then it is semantically much more informative for me to understand. But these are like nitty gritty details which I think is important. So I'm gonna stick with the variable names. Sometimes, like when it is a pointer, but I want to move by the size of the data, then in that case it becomes necessary to put size of type. But in that case also I can dereference it. I just too much into the core semantics, man. My bad. I just finished this soon. Now pack 16. U16 UINT 8 same buffer I'm packing, and then UINT, and I want to pack these 2 bytes. It is the same, right? This and this, like dereferencing would still give me a address. That means I'm storing it in a pointer, and then I'm moving head by value of size by 1 byte. But why I will avoid this right now is because of how, because I'm simply following this. I'll do the improvement parts later. First, let's keep the moving pieces as minimum as possible. Because I don't know what will break when I finish with this implementation. What comes first? I have to convert this into mm, host to network. I would say network order. That is much better. Now I'll call host to network short and pass in the value net order, and now I'll have to mem copy at the location which is um, wanted to buy this buffer, and the store is my net order and the size of nitty net order. See, semantically size of net order instead of size of 32-bit and size of 16-bit. Like size of 16-bit would be fine, but that wouldn't convey the meaning here. Now it is like pretty clear like this, whatever size of this, but if I say 16-bit, then I would have to see upward and see that, yeah, why it is 16-bit, because this is 16-bit. Or first thought of mine would have been in that case, let's say I put it 16. Now in this case I'll see something like store into this location from this location 2 bytes. But why 2 bytes? Okay, so it must be size of this, right? But if I do this, now it is clear. Still thinking. Cool. What do I have next? Is what is next? Now I have to move the head, which means I have consumed 2 bytes from this buffer or from the byte stream. Now I'll move it forward. Man, that's too much noise. What the fuck people do, man, at night? Like, why can't you be quiet? Next is 32. Same goes for that. I should have copy pasted this, bro, but I like typing. Pack what? Pack bytes. Okay, so that's why I don't have to do anything H2L or N2L for anything that goes beyond 4 bytes, because maybe I'm wrong. Yes, I'm wrong. Pack bytes from where to where? From the past string into the buffer. I can make it constant, right? String, because I'm reading from a string, so I don't have to modify the string. So I don't modify the data and I don't modify the pointer. Right. So in that case, I'll simply mem copy. But how much mem copy? This information is also encoded into here, right? How much is basically the length of this string? So you are basically strlen, which would give me size t strlen. It asks for str and then I mem copy from C style cast reinterpret cast man. I'm not using C++ Pro. What the fuck, man? This allows us to handle incoming. I should have done all of this in single stream. Like why? How did I break it into two streams, man? I just talk too much, huh? Like seriously, bro. How many how many characters are these to type? Like, my bad. I did this during those stream. Yeah, then it makes sense. Yeah, my bad. Back to MQTT module. After the creation of pack module, we should include it into the MQTT source. MQTT C file, huh? Yes, you are using. What does this mean? Include the directory when naming header files. Shut the fuck up. Shut the fuck up. File extension must be specified. Which file extension, man? I'm thinking of disabling this for this workspace. Where is the linter? Uh, yeah, we'll do that later. The first step will be to implement the fixed header remaining length functions. The MQTT documentation suggests a pseudocode implementation in one of the first paragraphs. We'll stick to that. It is quite simple and clear. We'll see why and how. After the first byte of the fixed header, the next 1 or 2 or 3 or 4 bytes are used to encode the remaining bytes of the packet. Is that? Okay. Pseudocode implementation, remaining length function. The remaining length is the number of bytes remaining within the current packet. Remaining length is the number of bytes remaining in the current packet, including data in the variable header and payload. The remaining length does not include the bytes used to encode the remaining length. Cool. The remaining length is encoded using a variable length encoding scheme, which uses a single byte for values up to 127. What? The remaining length is encoded using single length using a variable length encoding scheme, which uses a single byte for values up to 127, like the last bit. Larger values are handled as follows. The least significant 7 bits of each byte encode the data. The most significant bit is used to indicate that there are following bytes in the representation. I'm dumb. I can't understand. I have read this like couple of times in the official documentation as well as here, but it still doesn't make sense to me. Help me. Okay. I mean, I can't move forward if I don't understand this because I won't understand this. Hmm. This part is clear. The remaining length is encoded using a variable length encoding scheme which uses up to single byte for values up to 127 values larger that follows. The least significant 7 bit are, yeah, I understood that 7 bits are for data and the most significant bit is used to indicate that there are following bytes in the representation. Okay, so is this 1 or 0, right? So thus each byte encodes 128 values and continuation. Oh, okay. The maximum number of bytes in the remaining length field is 4. Eh? Maximum number of bytes. Okay, so the field itself can be of 4 bytes and each byte represent whether the whether the remaining data. Okay, understood. Sort of. It's roughly clear to me. For example, something like this. Uh, that is why it's taking too much time, because I'm explaining while I'm like this is your 8th bit, and this is your and this is your 7 bits. This is your 8th bit. Fonts are too large. Right, so this is your so what the documentation is saying that that this data is used for that this is your actual data, and this is like the blog says, it is a continuation. What is the spelling, bro? Continuation. Continuation. This is a continuation bit. So this saying that whether the following data that the following packet comes, how big that packet is going to be. Let's just say it actual data means actual data length means, let's just say if this bit said something like okay, so the if it had a value like 1 with let's say 1 2 3 4 5 6 7, if these bits would have been like this, then it would mean there is only 1 byte of data that is coming. In this case, this continuation bit would be 0, because there is no continuation for and there is 2 3 4. Okay, we gonna group them, duplicate it, 2, duplicate it, 3, 4. So this would mean like consider all these are 0. The fuck, man, like they don't exist. Right, so these are all 0. That means a continuation bit is for this next byte, because like the blog said, the remaining the maximum number of bytes in the length field is 4. So this is the remaining length field size. So the remaining length itself is so this is your remaining length field, right? So Cool. So this is your remaining length field size. I'm not sure what the continuation bit means. The least significant bit is 7, where the most significant bit represents the following byte in the that there are following byte in the representation. It is used to indicate that there are following bytes in the representation. Thus, each byte encodes 128 and a continuation bit. Right now, what how it makes sense to me is this: if this is like 1 byte, like if the value is 1, then there is only 1 byte data. So no need to check these, or like I'm trying to understand what this continuation bit is for. Like, is it for these following bytes or is it for something else? Because this directly tells me how big my data is. In this case, it would be 1 byte, right? If I say, if this is the value, then my data is going to be, remaining length is going to be 1 byte. If it is 1 0 0 2 3 4 5 6 7, if it is this, then my this is going to be 127 bytes. Then my data is going to be 127 bytes. Right. And no continuation bit. So the data itself is completely represented by this value, and this has to be for these remaining. And it is also saying that larger values and endless follow. The least significant 7 bit represents data, and the most significant bit is used to indicate that there are following bytes in the representation. Because this is the representation. Can make sense only, like this makes the only sense, like this is the representation, this is my actual data. So if it is like there is like 128 byte of data, in that case this would be 127, now remaining 1 bit. So I set this 1 means there are remaining bytes in the representation, so the continuation bit becomes 1, and in this case I say 1 2 3 4 5 6 7, say this means now I have 128 bytes of data. Okay, so you go through all these 4 bytes and then you stack up, then you use these values to get this length, and then from there you can use this length to get data from some byte stream. And using those, all those headers and pointers, those pack and unpack APIs that we wrote. Make sense? It does. So if I'm using this thing to get to encode and decode the length, then uh, I have to have some sort of logic to decode and encode length, and this is exactly what that logic is. And a remaining data field on the field header can be at most 4 bytes. So yeah, this is so encode remaining length on a MQTT packet header comprised of variable header and payload. If present, it does not take into account the bytes required to store itself. For implementation. So how do you do that? Encode length. This points to some buffer. This is some size. This is the length of this buffer. Now you do is +1 is greater than the maximum length, which is 4. First one is greater than 4 and simply return bytes. That would be so the update of this byte is happening where byte plus plus here. That means when the next iteration comes, this would already be updated. In that case, if initially it's 0, then it would be 3 plus 1, which is 4, and you use 4, then you make it 5, you comes here, it becomes 5 plus 1 6, or let's just say, okay, so let's just say that this is 2. In this case, there's nothing that checks byte, then you comes 2, you use 2, you increment it, becomes 3, you come in here, now you say 4. What kind of encoding is this? I'm not used to this do whiles and this kind of. So there's this checking of length also, and the length is also, length is divided by, so length is decreasing, and there's some bound checking, like it keeps the length between 0 and 127, and then it divides the length. If it is still greater than 0, means you OR this t, then you put that data into buffer and you return bytes. Yeah, I have to take a concrete example to understand this. See, I'm not very bright. Initially this is 0, makes sense. Now you say 0 plus 1, which is 1, greater than 4. Nope. So you come in here and now you say that this is the length. And what is this length? I'm trying to make sense. Is it encode length? Buffer is, sorry, byte is still 0 plus 1, it becomes 1. This doesn't concern me in my current iteration when byte is 0, when bytes equals to 0. Now I take this length. So let's take the first scenario where the length is between 0 and 127, including 127. In that case, this would return 0. So you basically say this no. In that case, the data would be length. You take module, this is your upper bound actually. So whenever the length hits 128, this becomes 0. So between 0 and 127, the D would vary from 0 to 127. Okay, so the range of D becomes 0 to 127. Now what this does is you divide length and then you make it equate. What does it do? It is an integer division. So if when my length is 127, in this case D is 127, and length is equals to length divided by 127, that means 128, that means 127 divided by 128 would give me 0. But if length is if I say something like this, if my length is a multiple of 128, so length multiply by 128. Now let's just say what I'm trying to do is length. Let's just say that my value length is equals to some number and it is a multiple of 128. In that case, hmm, if this is a multiple of 128, this range would vary from I think let's consider two cases when length is 127 and when length is 128, because that is the um, so when my length is 127, d becomes 127, len divided by 127 divided by 128 will becomes 0. If there are more digits to encode at the top bit of this digit, if this is 127 then length becomes 0, and if len is greater than 0, well, this is false, so I don't do this, and then I say the bytes is 0. At 0 I put 127, meaning some buffer gets a value like this: 1 2 3 4 5 6 7. Some buffer gets this value, and now I increase byte to 1. Now I say length is greater than 0. Well, it is not greater than 0. That means I have finished with the encoding, since this is exactly 127. Oh, so that's why it was required, because if my data is 128 and I'm using only 7 bits, then how would I indicate that there are remaining data, that data is greater than 127? 127, 127, 127, 127. 127 times 127 squared is how long I can send. Okay, so this is one understanding. Let's just say, consider scenario when LE length is like 120, 128 is the length. Okay, so at this buffer there is some data stored already, and I have to encode the length of this buffer. No, but because I'm modifying the buffer here. Yeah, which I have to, because the initial bytes of any packet contains the length information. In that case, before I fill data in this buffer, I have to encode length into this buffer, the length of the incoming data. And for that, I first call this function, then I'll put data into the buffer. Make sense? Okay, so the in case when the length is 128, then this 128 divided by 128, so d is 0. So d will become 0 only if my length is greater than 127. When that happens, then I say, what is division actually achieving? Is that if this value becomes 128, then this length will become 1. And in case the length is already a multiple of some, so if in case it is just 128, then this becomes 1. But if it is some multiple of 128, then the expression len equals to len divided by 128, this would essentially say 128 multiplied by n. That means just a number and given n is greater than 0. Mm, that would mean that len greater than 0, and now I can make condition that if len is greater than 0, that means I have data at the 8th bit, or I can set the continuation bit. So when my length is 128, this becomes 1, this becomes true. I say this. So how do you write 128? 128 is written like this, like 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. It is written like this, like 128. My bad. Guys, this is not 127. This is 1, 2, 3, 4, 5, 6, 7. This is 127. The last one is 128. Now if I take AND with this, sorry, OR with this, which is D, initially this would be 128 divided by this equals 0, and I say OR, bitwise OR. If I make like D is equals to 128, like D is 128, and D is 128 would definitely make it 1 at this bit. So 3, 4, 5, 6, 7, 8. So 7th, 8th bit at position 7 will be set. But if, but what if this L in, like this case, when it is a multiple of some 128, right? In this case, D would already contain some value. Let's just say I in this case, let's just say D would already contain some value. So let's say 128 times 128. What is this? This is this. Now if I take mod, where is mod? Mod 128. How much is this? It is exactly 0. Makes sense. Length will all be, so this would run only if this is greater than 0, which means uh, 128 multiplied by 127 mod 128. Well, that's still multiplied by 127. That means 127 multiplied by some number 127 equals to this. Take mod with 128. Let's just set all the bits. Now what if I take mod by 128? Now it is 127. So now the D would, when length is greater than 0, D would contain the value 127. And now in this case, if I assign it directly, then the value gets destroyed, but 127 taking OR with 128, give me this. So that is why it is a bitwise OR and not the assignment operator, because this could be greater than 0. I clearly meant this. No, it was not clear, because if it is 127, like 255 greater mod 128 gave me 127. In that case, I set the top bit and I say the byte is my current byte plus 1. I return bytes. Short D 16 bit. 128. Take my first zeroth byte. I say 1 is greater than. uh, First, it will not run. It will do something. Like, let's just say that length is something that would fill all these bytes. In that case, whatever this thing doesn't matter. Bytes is 0. At 0th byte you would store this value, and you increment it, becomes 1. Length, I'm still saying that's greater than 0. So my byte has become 1. Now I say, when my byte was 0th byte has I already failed 0th byte. And I incremented by 1. It becomes 1, comes in here. 1 plus 1, 2. It runs. It was 1. So it put value at 1 index. Make it 2. Come in here. 2 plus 1 is still, come in here. Put value at 2. Make it 3. 4 is not greater than 4. Come in here. Put value at 3. You make it 4. Come in here. 5 is greater than 5. Right now I'm just gonna write it as it is, and later on I'll improve on this. I'll make it much more quote unquote modern. I'm a very whiny guy, man. I just bitch too much. I don't know why, but like, having an elegant code is becomes necessity for me. Sometimes it becomes unhealthy, but I like unhealthy things. Now let's move on to .c file. Okie dokie. Now let's we come on to the meet. Mqtt.c. Is this C file all along? Hmm. Now I define max lang byte. These are static, so another semantic thing that I don't like to do is having function prototypes in my code, and this goes specifically for static ones. I don't like having function prototype. It just pollutes the code. So I'll write from here and push them downward. Or I'll first make it compile, then I'll move on to things. I say encode length. Do I have this somewhere in the function prototype level? Encode length. MQTT encode length. Buffer and length. I am moving the pointer in here or not? I'm modifying the contents of the buffer, but I'm not modifying the buffer pointer. Is it so? Yeah, I'm modifying the content, but I'm not modifying the. So I'll say something like this. What are we doing in this? I'm counting like how many bytes have been do things if my bytes plus 1 is greater than max something return while length is greater than 0 means I have things to encode. Or I'll improve it right now. Or I'm not very confident. We'll do that. Like my mind is thinking something else. Okay, let's just implement this first and we'll see. So byte 1 plus 1 whatever it is, then I'll say my byte is 0 max length, so if it is greater than 4 byte, so the byte will vary from 0 to 3. Encoded bytes will vary from 0 to 3. No, 0 to 4. Okay, so but this is like you are up checking after you have updated. So you updated in previous iteration. And that is why you have to bound check with 1. Because once you have written at index 3, then you have updated the byte to index 4. And That should be it, right? Like, yeah, whatever. Now I'll say I'll get the dn length. Okay. What do I call it? Should I call it continuation bit? But that is, I can make it simpler, like more readable. For like, for example, here the data and the continuation bit are, why is it a short? Are in the same, like it is not clear to me. Right? I have to read it. The data and continuation bit. I can say something like length modulus 128. This would give me value from 0 to 127. That means it can maximum take 0 to 127. So if it has some value like 127 already, then I calculate this. This would tell me whether there is a remaining data or not. If there is remaining data, only then you set the last bit. I think it is pretty clear. It is pretty readable once I know the algorithm. But readability is not for the one who knows it. It is for the one who don't know it. That's how readability is measured, right? And if I know it, then it is readable for me. If I don't, then it is not readable for me. It has nothing to do with the way I write or the way I encode or the way I think, whatever that is. Like I said, let's just implement for now and come on to the improvements later. I always mix these two things. So I'll say, first of all, it need not have to be short because this will never go beyond 127. As soon as it goes, it will be back to, so I'll say data is equals to length modulus 128, and length divided by 128. This would tell me if there is remaining data or not. If there is remaining data, that means you do something like this. What do you call 128 in hexadecimal? That would be like setting the last, which is one, bro, it's 1 byte. So this is 255. This is 128. It's 240. 16. Of course it is 16. How do I put 128 in hexadecimal? Let me think about this. This is good because I can do it. If this is 16, And this is 256. 128. 128 would be 0, 0, 7 zeros and 1. That is binary, man. In decimal, from going from 128. What is the 16 squared is 1256. So it can't go at this location. It has to come here. What is the multiple of 16 that is very close to 128? For that I have to remember the 16 thing. Like first is 16, then it is 32, 32 plus 16, 48. It is definitely 10 is 168 is 80 plus 48. Show that it is 9 something. 90 plus 16. 106. Boy, I don't know, man. Just taking too much time. I'll write 128. But what is it? 80. Like 16 times 8. What is 16 times 8? 80 plus 80 plus 48. Hmm, it is. So, but why did I go to 90 then? It is 90 plus 54. 90 plus 54. That goes way beyond 128. Cool. Now I put this data into like uh this is the encoding thing that is happening. Like now initially no, it was never initially, it was always this thing that was cool. And if that is, then I put buffer at location bytes plus plus is equals to data. I have encoded the length. Why am I doing this? To indicate their There is more to encode. And set the continuation bit that says it all. And buffer, I'm already putting the data. It's pretty straightforward when I think about it now, because I've done the thinking already. I've suffered, so I know the simpler route now. Simply saying, which like it was clear from the beginning, says if my length is greater than 128, then I get the 127 initial 127 bytes, and so modulus give me lower part, division gives me the highest part, and then I check, put bit, makes sense, cool, pretty easy now, not earlier. Decode length, handle case where multiplier is greater than 128, 128, 128. I don't know about that. Cool. Hmm. I think this will take some time also. We'll catch it up later in the next stream. Cool. See ya.